Welcome, curious minds, to another deep dive. We're really thrilled you could join us for these discussions organized by Smart-EDU Hub today. Our topic, well, it's AI's journey from idea to educational transformation. We're about to unpack some truly powerful stuff that's reshaping our world.
Yeah, our main source for this deep dive is this really comprehensive paper by Cattell and Vrabey. It offers quite a profound look into AI's evolution and its impact, especially within education. So our mission today is basically to figure out how AI moves from just abstract ideas to actual practical tools and really focus on how it's transforming learning itself. Get ready for some hopefully genuine insights.
Oh, absolutely. And it's remarkable how relevant this is to, well, everyone. AI isn't just stuck in labs or tech companies anymore. It's actively reshaping our daily lives. And education is such a prime example of that. Cattell and Vrabey's paper, it takes us on this fascinating journey starting with AI's history through modern applications and, importantly, those difficult AI winters.
Right, the winters. Where things seem to stall and then the big resurgences that follow. It's really a story of human ingenuity and just sticking with it.
So, okay, let's unpack this term artificial intelligence. We hear it all the time, don't we? And it's often used pretty loosely, sometimes just for simple computer tasks or, I don't know, regular databases. But the real challenge is there isn't just one single definition everyone agrees on. It's so broad. It covers logic, understanding, planning, creativity, problem solving, and crucially, learning. And when you think about the words themselves, artificial, so not natural, and intelligence, which we think of as, well, human, like Howard Gardner's idea about solving problems in cultural contexts.
Yeah.
It almost sounds contradictory, doesn't it?
And that brings up a really key distinction, which is what kind of AI are we actually talking about? We need to separate narrow AI from general AI. Think of narrow AI as like a specialist. It's a system built for very specific tasks, playing chess maybe, or recognizing faces. That's all the AI we currently have, really.
Right, just focused tasks.
So exactly. General AI, now that's the big goal. Systems that could potentially solve problems like humans do across different areas adapt. It's a huge scientific interest, but honestly, it's still years, maybe decades away.
So for our discussion, we're looking at these sophisticated machines that exhibit seemingly intelligent behavior. But yeah, the reality, as its history shows, is way more complex than that catchy phrase.
Okay, so the whole modern idea of intelligent systems, it really kicks off around 1950 with Alan Turing's big paper, Computing Machinery and Intelligence. Even back then, people were thinking about automatic computation for complex math or chess. Turing saw that defining intelligence for machines was tough. So he proposed the Turing Test, right? That 5-minute text chat idea, if you can't tell human from machine, the machine passes as intelligent. And it's interesting, Ada Lovelace, way back in 1842, was skeptical. She said machines couldn't originate anything, but Turing kind of pushed back, suggesting we could program them to be original, to give unpredictable answers. And his core idea, the really mind-bending one, was that there's no fundamental reason machines couldn't eventually achieve thought. Wow, that must have sounded radical.
Well, completely radical. And Turing's thinking really set the stage for AI becoming a proper field. That key moment was 1955, with a proposal for the Dartmouth Summer Research Project on artificial intelligence. This wasn't just some conference. It was incredibly ambitious. Pioneers like John McCarthy and Marvin Minsky basically tried to map out AI's future right there. And the amazing insight is, their initial vision was so spot on that many things we see today, NLP, self-driving concepts, they were literally thinking about them back then.
Wow.
Yeah. They wanted machines that could reason, solve algebra, diagnose diseases, even understand the world, which meant creating programming languages. They also looked at navigation, planning routes, and crucially, understanding and using human language, natural language processing, NLP. That drive even led to Romania's first automatic English to Romanian translation in 1962. And finally, perception sensors, machines learning from experience almost like kids do.
Those early days had some real breakthroughs, too, like John McCarthy's list in '58 that became a core language for AI work, a huge step forward. And Marvin Minsky was really pushing the idea that context is critical for AI to make sense of things. Then in '61, James Slagle's St. Teat program could actually solve calculus problems. That was a major milestone for that first wave. And even here in Romania, the MECI PT1 computer developed in '65 was used for big architectural designs, the Romexpo Dome, the Vidroier Dam, practical stuff really early on.
And if you connect all these historical efforts, the big lesson is about representation. Accurately representing how thinking works is just fundamental to AI. Think of AI not just as code, but as systems building internal maps or models of reality. That's representation. The key insight, I think, is that AI isn't just crunching numbers. It's building its own internal view of the world. That's how it learns to think or act, like lead soldiers representing troops or math symbols or maps. They're all models. So a more refined definition, AI is like an architectural system, using methods based on constraints revealed through these representations, supporting models of thinking, perception, action, and, learning.
Okay, that makes sense. Which then leads us to the mid-70s, the second wave, right? With the rise of expert systems, like Edward Shortlift's MyCIN, diagnosing medical stuff pretty accurately. But then came the mid-80s, and that AI winter you mentioned, promises seemed too big, startups failed, AI got a bit of bad rap. Tough time for perception, but as you said, the actual knowledge kept advancing quietly underneath.
Exactly. And that quiet work eventually fueled this dramatic third wave, a real AI renaissance. Think about 1996, Deep Blue beating Garry Kasparov in chess the next year. Huge moment. Showed computation could challenge human intellect at that level.
I remember that.
Yeah. Then Siri in 2010, talking to iPhones, and IBM Watson winning Jeopardy in 2011. That really signaled a comeback. Tech giants jumped in heavily, fueled by all this online data, big data, and just massive increases in computing power. And this brought back machine learning, neural networks, in a big way, especially after Geoffrey Hinton's work on image classification around 2012.
So where does that leave us now? Neural networks are powerful, definitely, but it's good to remember they're mostly recognition algorithms. They don't think or see like we do cognitively. And you still get that techno-skepticism, like the famous story of the Tesla mistaking the moon for a yellow traffic light. Gets a lot of laughs. But the paper makes a good point. Comparing AI directly to natural things can be misleading. Airplane wings aren't bird wings, right? Both fly, but they're different. We shouldn't expect AI to perfectly mimic human thought. And this whole debate about existential threats, it's fascinating. You have Elon Musk famously calling AI summoning the demon our biggest threat, which echoes Marvin Minsky back in 1970 worrying we'd become pets to computers.
Strong warnings.
But then others, like Edward Feigenbaum, argued rule-based systems could keep things safe. And it's interesting, even Musk, despite his warnings, has invested heavily in AI recently, so it's not about taking sides, maybe, but seeing that even the critics are deeply involved.
Absolutely. And it's clear that while deep learning is state-of-the-art, AI is more than just brute force computing and big data. The next step really seems to be these insight systems, ones that can summarize, conceptualize, even generate content. We are talking about self-awareness, but honestly, it's still extremely basic. Current science doesn't really even see it as a near-term possibility. What's really important to grasp is that successful AI often automates routine stuff or helps humans and machines work together, getting results neither could alone. And for AI to be truly trustworthy, it needs to explain itself better. That means systems that can reason and learn more transparently.
Which brings up those two key questions we always need to ask. Okay, what should computers do and what should humans do? And how do we make this whole human-machine team better over time? The best approach seems to be playing to strengths. Machines are amazing at storing and recalling huge amounts of info super fast. Humans, we're generally better at social stuff, tricky decisions, creative thinking outside the box.
Right, it's about symbiosis, not replacement.
Exactly. Think about Google search. It democratized information, sure, but also created whole new job categories. Or Wikipedia, humans write the content, but bots help manage things like vandalism. Cybersecurity is another great example. Antivirus software, that's the machine detecting odd patterns. But humans make the final call on what's a real threat. That combination is just way more effective.
Yeah, and to understand that division better, we can look at AI's different roles. First, AI just as tools. Simple stuff, really. Word processors, spreadsheets, cruise control, even email filters or Netflix suggestions. They just help us connect and decide. Then you step up to assistants. Google indexing the web is like a global assistant librarian. Semi-autonomous cars assist the driver. IBM Watson helps doctors sift through medical research. Chatbots suggest replies for customer service agents, making the human more efficient.
Okay, tools and assistants.
Then it gets more interesting with AI acting almost as equals. Think about Lemonade Insurance, using AI to approve simple claims instantly, only passing complex ones to humans. Or AlphaZero, the chess AI, acting like a trainer for champions like Magnus Carlsen, fighting strategies humans missed. There are even Centaur chess teams, human plus computer, often beating both humans and AI alone. We see this in stock trading bots, social media aggregators too. They act like peers.
Equals wow.
And finally, AI can even be managers. Traffic lights manage intersections instead of police officers. Carnegie Mellon had crowd-forged coordinate humans writing articles. The AI assigned tasks, assembled paragraphs, and the result was better quality for the cost. Or the Cogito system, giving real-time feedback to call center reps on their emotional tone. So it's managing and improving human processes.
That idea of the human-computer partnership evolving, like Andy Clark suggested, it makes sense. It's a system getting smarter together. And there are, three main ways it improves. First, us humans, we streamline our processes, get better at working with the tech. Second, the programmers, folks at Google, Meta, constantly refining the algorithms, making the machines better.
Right.
And third, maybe the coolest part, is machine self-improvement. When we correct a chatbot, for instance, it actually learns from that correction. It gets better at sounding human or giving the right answer next time. The future seems to be about smarter apps that don't just do things, but can explain why and understand us better, improving our lives.
And that perfectly leads us to the core focus of Cattell and Vrabe's research, AI transforming education. The Smart-EDU Hub project, digital media for enhancing educational quality, actually showed empirically that using AI and gamification really boosts student engagement and how much they remember. And it's vital here to get the difference between digitization and digitalization. Think of it like this. Digitization is just scanning a book to PDF. It's digital but static.
Just a copy.
Exactly. Digitalization is when that PDF becomes interactive. AI tracks your reading, suggests other relevant stuff, maybe creates personalized quizzes based on what you struggled with. One's a copy, the other's a dynamic, smart transformation focused on you, the user.
Okay, yeah, that distinction is key. And this is where education gets really exciting, isn't it? As we move into Education 3.0, universities have to adapt to these technologies. We know e-learning platforms boost performance. But imagine AI as this pedagogical adjunct, like a teaching assistant. We're talking systems that could translate materials for different learning styles or generate quizzes tailored to your specific profile. Maybe you're visual or learn best through sports analogies or you're an extrovert.
Personalized pathways.
Exactly. Virtual assistants, like GPT-4 level models, could explain concepts further, find specific resources just for you, making learning truly individual.
And building on that personalization, think about career development. So many young people, understandably, find it hard to figure that career path. You could have an AI advisor that goes beyond just matching skills to job titles. It could subtly pick up on your hobbies, your real interests, your talents, even how you handle stress. By comparing that to patterns from millions of professionals, it could suggest really tailored career paths, maybe things you'd never considered. It could help students find opportunities that genuinely fit them, boosting their potential and hopefully their job satisfaction.
So wrapping up this deep dive on AI's journey, especially in education, what are the key takeaways for actually using it well? First, these AI systems, particularly for education, absolutely need solid, accurate knowledge bases from reliable academic sources, not just scraping the web.
Crucial. Garbage in, garbage out, right?
Right. Second, real personalization needs a deep dive into user psychographics, learning styles, interests, much deeper than basic demographics. And finally, human expertise isn't going away. It's essential. We need humans to correct errors, provide judgment, be that final check on the system.
Which leads to maybe a final thought for everyone listening. How will we adapt? We're definitely in the early days of this AI era, and it's already opened up possibilities we couldn't imagine before. Yes, there are risks. We saw how platforms like Facebook started with good intentions, ended up having unintended negative consequences like impacting elections. But those risks shouldn't blind us to the benefits. History shows societies adapt to new technologies, even risky ones. The potential for progress here is just huge if we approach it thoughtfully. So maybe think about how could you use these ideas to better understand or engage with the smart tech shaping your own world, especially your learning.
That's a great question to end on. Thank you so much for joining us on this deep dive. If you enjoyed our discussion and want to catch future deep dives, please do remember to like and subscribe to the Smart-EDU Hub channel. We really appreciate you tuning in.